This topic will demonstrate how to create a new TransModeler project based on an HCS streets model. This method is ideal if your project happens to involve using HCS and TransModeler to evaluate traffic operations and level of service. There are two different ways of making this happen, both of which we'll demonstrate in this video. The streets file we're working with is a corridor of 3 intersections in the example study area, starting at Henderson Road and ending at Bethel Road. There's also some curvature added in segment number 2. The more detail you're able to add in terms of the curvature in HCS, the more accurately it will be imported when creating the network in TransModeler. The first method is quick animation. This is simply exporting the file from HCS streets and directly opening it in TransModeler and launching the simulation immediately. No geo-referencing takes place, and no adjustments are made beforehand. So we'll close TransModeler because it will open anyway, and we can select either File, TransModeler, View Animation, or simply click the TransModeler icon found in the toolbar for quick animation. So the simulation database is generated on a blank map, and the simulation begins right away. There are several project settings preset that happen anytime you do a quick animation from HCS. Among those, delay and level of service is already being collected at all of the nodes. You don't have to make that specification as you normally would. The quick animation method is primarily for checking the operations that are occurring between the intersections, making sure that the results you're seeing in HCS add up with what you're seeing in the simulation. If you want to retain the files that were created during the quick animation step, you can go to Documents, Caliper, TransModeler SE 6.0, and a new subfolder called HCS Datasets will have been created. A subfolder titled the name of your HCS file is created in this folder, and all of the simulation database and input files required to run the simulation have automatically been named and created and stored here. If you rerun quick animation after closing out this simulation project, all of those files will simply be overwritten. So if you want to keep them, make sure to move them somewhere where they won't be overwritten. If you close the project while a simulation is running, you will be asked to confirm you want to end the current simulation. You can click Yes. The next warning you get describes what I just explained about copying files to a different location if you don't want them to be overwritten. Click OK. The final warning you might receive asks you if you want to keep your simulation output even though the simulation didn't finish. Click No. The second method takes a little bit more effort, but it basically is the same process, except we will be geo-referencing these intersections onto the real-world coordinates. Geo-referencing allows you to take advantage of all of the GIS capabilities in the software, including automatically loading satellite and other web map imagery. To do this, you need to start in TransModeler, go to File, Import Traffic Data, HCS file. So we'll select the HCS streets file. This window is asking us to pick a folder where all of the required simulation files will be created. We have the simulation project, the SMP file, the simulation database that stores all the lane and road network geometry, the signal timings to store all the signal phasing settings, and the turning movement volumes, which are created automatically and assigned to each intersection. So in this case, this is the first file we're creating in this folder, so no need to overwrite any existing files. Click OK. And this is the key step in which we'll be georeferencing the file onto real-world coordinates. Choosing to not georeference the model is the equivalent to doing the quick animation step. So in other words, it will just be projected onto a blank map at coordinates 0, 0. So in this case, we want to select the second option and choose the location. The Create a Map wizard will allow you to pick the location where the map will be centered on when we open. So we'll go with Columbus as the city, and for the map layer, we'll pick Google Satellite. You may wish to review Google's terms of service prior to using the Google Satellite Web Map service. So now we have two separate windows. On the left side, we see the same HCS network represented as a stick figure network, where you can see the links and nodes positioned according to the coordinates that they were assigned in HCS streets. On the right side, we have a new map window, and the idea here is to find the location where these intersections belong and assign each of the nodes to those exact locations. So we'll go to the study area here and find our first intersection. So in the line layer model, on the left side, we'll select point 1 to represent intersection 1, assign that to this location on the map, and then do the same for numbers 2 and 3. So now in this window we can see the 3 points that were selected that will map these HCS streets coordinates onto real world coordinates. If you happen to make a mistake and want to do this again, you can save these points as a coordinates file. That way, the step of assigning points 1, 2, and 3 to those exact locations will already be done, and you can simply click Load Points next time, if needed. So now that we have our points set, we'll click Continue, and the simulation database will be created and projected onto the map. You'll want to inspect all the links and nodes, make sure they're lined up the way they should be. It looks like they're mostly located at the correct locations. There is some road editing network that will be involved, making sure, for example, this southbound link is rotated over to reflect the skew angle here. But overall, the majority of the roadway editing network that would have been required has already been done here. So other than the road editing required, all of the other project settings and inputs are set up and ready to simulate right away.